Hello friends, let us solve some previous year gate questions from the topic stability of slopes. Okay, let us first see the problem. The soil profile above the rock surface for a 25 degrees infinite slope is shown in figure, where SG is undrained shear strength and gamma T is the total unit weight. The slip will occur at a depth of. So, what about the here? Is it a uniform soil or a stratified soil? Stratified soil, right? Why? Because up to 5 meter we are having different properties soil A, and in the next 5 meter we are having some soil B. And if we see, the parameters are also different. So here you have to find at what depth the slip will occur. So when you can identify the depth, wherever you can say the factor of safety is equal to 1, then the failure will occur. Not failure will occur, it will be ready to failure. So that's why we will find out a depth at which your factor of safety is equal to 1. So even if you cross that point, if you cross the depth, the failure will occur. So that is what our main motive. Now, what is our factor of safety in general equation? That will be equal to shear strength divided by, what about here? Shear stress acting on the layer where you are finding the factor of safety. If you see here, the shear strength is given up to 5 meters how much? 40. The shear strength is below the 5 meter is 60, isn't it? So first, do we know whether the failure occur in the first soil A or whether the soil failure will occur in the portion soil B? Do we know that initially? We don't know, right? So for that, what we have to find? Let us say that let us check the factor of safety at the junction between these two layers. If the factor of safety comes greater than 1, then we can say the soil above that level will be safe. So for that, what we have to find? We have to find out the tau. So how can you find the tau here? So for that, let me draw some conclusion here. Let me tell you, suppose already we have discussed in the theory, if there is an angle I, if you want to find the shear stress along this level, so what we have done, we have considered a small element. So what about the total weight of this element? If you do remember, that will be gamma into h into cos I. So this is what the total weight up to a depth of h. So if you resolve this force, self-weight along the tangential and normal direction, along the tangential direction, gamma h into cos I into, you will get sin I. So gamma h cos I is the weight. If it is a complete horizontal level, then we can say simply gamma into h. But it is an inclined level. If it is inclined level, what about the self-weight? That is nothing but a gamma h into cos I. So for that we have to multiply sin I. Then you will get the component along the tangential direction. Otherwise you can say shear stress that will be equal to what is the normal self-weight component? Gamma into h into cos I. If you multiply by the sin I, then you will get the stress along the tangential direction. Okay, now let us say first you are evaluating, you are finding the factor of safety at a junction of those two layers. So what is the depth of the soil A? 5 meter. And what about the gamma value given? Gamma value given as 16, SU will be 40. Gamma value given as 16 and the shear strength will be given as 40. Now what about the shear strength? Directly we know that will be equal to 40. What about the shear stress? That will be equal to gamma into h into cos I. This is the stress that is acting in truly vertical direction multiplied by the sin I. Then you are getting the tangential component. Now, what about the gamma here? Gamma is nothing but a 16. What about the height? 5. And what about the cos I? That is nothing but a cos. What about the slope? 25 degrees. And what about sine? 25 degrees. Tell me how much you are getting this tau. Do the calculation and tell me. Cos 25 into sin 25 into 16 into 5. Then you are getting this value around 30.64 kilopascal. That means what about the factor of safety? Factor of safety that will be equal to shear strength divided by shear stress. What is the shear strength? 40. What about the shear stress? 30.64. By comparing this, you can say the factor of safety is greater than 1. That means what we can say? It is a safe up to a depth of 5 meter. So the failure is not going to happen in the soil A. So if the failure is not going to happen in soil A, then obviously the soil is going to fail in the soil B part. Let us assume that your soil is failing at a depth h below the soil A. So from up to here, what is the depth here from here to here? 5 meter. Let us assume that this is the critical slope. If it is a critical slope, then what we can say? Factor of safety is equal to 1. So if I say factor of safety is equal to 1, that will be equal to shear strength divided by shear stress. That implies shear strength should be equal to shear stress. What about the properties here? Here it will be 16 kilonewton per meter cube. Here what is the gamma? What is the gamma there? 20. And shear strength is 60. 20 kilonewton per meter cube. Along this layer, your shear strength is 60 kilonewton per meter square. Now, how to find the shear stress? That will be equal to, first we have to find out the stress normal to the stress truly vertical direction. What is the stress truly along vertical direction? What about the weight? What about the stress from the soil 1, soil A, and what about the stress from the soil B? From the soil 1, what is the vertical stress? That is nothing but a gamma into h into cos I. What about the gamma here? 16 into what about the height? 5 into cos 25 plus. And what about up to the depth of h? Gamma is nothing but a 20 into up to how much depth you are considering? Let us say h into cos 25 into, if you want to find the shear stress, multiply by the sine 25. So this is nothing but a undrained shear strength. So that will be equal to 60. That will be equal to 16 into 5. How much? 90. I will take cos 25 common. 90 plus 20 times h into cos 25 into sine 25. So from this you are getting the h value. So solve this and tell me how much you are getting h value. So if you solve this, you are getting your h value as equal to 8 point, no, sorry, if you solve this, you are getting h value is around 3.83 meters. This h is measured from below 5 meter from ground surface. So what is the question given? What is the question given? The slip will occur at a depth of, did they mention anything about the reference point? No. If they have not mentioned any reference point, then we have to consider from the top surface. From top surface, what is the value? 5. From here to here, 3.8. So from top surface, what is the value? 5 plus 3.83. So the failure will occur at a depth of 8.83 meters. So is there an option? Right. Option A is there. So option A is the correct answer. So in this problem, we have to understand that if it is an infinite slope, first we have to find the stress acting truly along vertical direction. That is nothing but a gamma h into cos I. This stress you have to resolve it to normal direction and you have to resolve it into tangential direction. In the tangential direction, it will be gamma h cos I into sin I. In the normal component, that will be gamma h cos square I. So you have to remember that stress truly along vertical direction is gamma into h into cos I. So you know what the students will commit the mistake in this question. They will commit that 16 into 5 plus 20 into h into cos 25 into sin 25. They will write down them, but that is not correct. Okay. This is what about the given problem. Okay. In the next video, we'll see another problem. Thank you.